Welcome back. In this video, we're going to have a look at how we can derive a rule that will allow us to analyze non-right angled triangles. More specifically, we're going to have a look at how we derive the sine rule. Over here, we've got a non-right angled triangle. With this non-right angled triangle, I'm going to label the sides and the angles. So I'll call this angle here angle B, and therefore this side must be A. This angle over here will be B, and therefore this side is lowercase b. And finally, this angle up here is C, and the one down here is lowercase c. Now, using our sine, cosine, and tangent ratios, we would not be able to easily analyze this triangle, but rather, we're going to do a transformation first. I'm going to go from angle C here. I'm going to split the triangle into two smaller triangles. And because I'm splitting it like this, I'm going to cut it such that the line that I've just made intersects side C at right angles. Alright, now that we've got this out of the way, we're going to analyze it, but we're not going to use angle C anymore, so I'll get rid of that, and we're not going to use side C, so that can go as well. Now my next step is I'm going to label these two smaller triangles as if they were right angled triangles. So we've got the hypotenuse in place of B, so we'll call that H1. And for side A, this is also a hypotenuse, so we'll call that H2. Now the angle that's opposite A and B, we'll call that side O. We won't give it a letter like A or B for now, we'll just leave it as O. And this is all the details we need. Now the next step is I'm going to write a rule for the triangle on the left here to explain the ratio that side or the opposite side makes with the hypotenuse. So we're going to go sine A is equal to the ratio that it makes with O and H. O and H1. And if we rewrite that using the letters, entirely using the letters for non-right angled triangles, we get O and B. Alright, so this is number 1. Now we're going to do the same for the triangle on the right here. So we're going to go sine B is equal to the ratio of the opposite over H2. And thus, rearranging sine B is equal to the ratio of opposite over A. And we'll call this number. Now what I'm going to do is I'm going to rearrange both of these new equations such that they're in terms of the opposite. So rearranging that, we're going to go opposite is equal to, actually no, we'll do it the other way. We'll go opposite on the right hand side is equal to B sine A. And over here, the opposite is going to be equal to A sine B. Now looking at this, we've got B sine A is equal to the opposite, and the opposite is equal to A sine B over here. So what you're going to find is that both of these equations are equal to one another because they share a common opposite side here. So what we can now do is bring them together. So what that will look like is B sine A is equal to A sine B. And now rearranging, so we have all of the A's and the B's on different sides. We're going to get sine A over A is equal to sine B over B. And conversely, if sine A over A is equal to sine B over B, then A over sine A is also equal to B over sine B. So what we've got here are the sine rules, or the sine rule. And what the sine rule allows us to do is it allows us to be able to analyze non-right angled triangles when we have two sides and an angle, or two angles and a side. So now what we can do by extension is that if sine A over A is equal to sine B over B, then that means that sine C over c must be equal to these two here as well. And similarly, we can also say that lowercase c over sine c is equal to these two ratios that the side makes with the angle as well. So we can put in angle c and lowercase c here, back up there. So this is the complete version of the sine rule here.